and, you know, look at the recordings, okay? But um, we are going to today basically go through and talk about the next step, okay, for using valence electrons, and that is going to be doing Lewis structures. So we're going to talk about Lewis today. Lewis was like one of the more hated scientists of his time. Nobody liked him. And we're going to talk about what he did. He did something really great, but his personality was just the worst. Okay, so we're going to go through and talk about that. The other thing that we need to touch on is attendance. Okay, most of us, to be honest, the vast majority of us are doing a very, very good job of being here every day, or you know, saying, hey, I couldn't be here, what did I miss, or whatever, and that sort of thing. So just keep that up. I know it does get harder as the quarter progresses. You know, people have things going on, you know, all that kind of stuff. Like, I got to run out to the middle of nowhere to my mom's house after class and all that kind of stuff. So I get it. We got to make sure that we're pushing through and that we're here every day, because we do have a whole bunch of stuff to go over. Okay. So that's the one thing. The other thing is, okay, grades and things, I will be, I've already updated it, but I will make sure that it's synced to go through to PowerSchool. Okay. For the most part, with the exception of your notebook check, because I gave you a little bit of extra time, for the most part, you guys are caught up in terms of me grading your stuff. So that's going to be, you know, something that you need to go through and look at, and you need to make sure that you are maintaining yourself, okay? Because what I don't want to happen is at the end of the quarter, you know, everybody start to rush and say, hey, man, I need to get this done. Oh, I need to get this done. Hey, I need to get this done, okay? The absolute last day to get anything done for our quarter is March 8th. Yeah, that's not that long from now. Okay, so we got to make sure that we are caught up, okay, as soon as humanly possible, okay, because we don't want to be behind going into March. Okay, you know, February is like in a day or two, you know, so we got to make sure that we are caught up, all right, and going through and taking each piece at one thing at a time to go through and look at it. Okay, so we're going to talk about valence electrons, okay, and we're going to use valence electrons to go through and talk about the Lewis dot structures. Okay, so we're going to do some of the Lewis dot structures on our own. Okay, and some people did not finish the Bohr model stuff from yesterday. That's okay. Okay, we're gonna have time today to work on that as well. And you know that stuff is not due until, I think it was Monday. I'll double check, but anyway, it wasn't due, at least, you know, not today, and things like that. So first off, we're going to talk a little bit about the valence electrons, and then we are going to look at the next thing. So for those of you who were not here yesterday, or just didn't quite get it, you know, and all of that, that's all right. But when you look at this, we're going to go in and do the warm up here in a second. But basically, when you look at your periodic table, you can tell how many valence electrons something has by what family it is in, or what group it is in. Those are the same things, family or group. So in group one, you have one valence electron. Okay, that means, we're going to talk about it today, but that means that you have one electron to share. Okay, now a few people went in and said, you know, like if you were given cesium, cesium does have 55 electrons total. However, it only has one that's available to share. So if you remember what we talked about yesterday, you cannot have more than, you write it down, cannot have, of course, I'd pick a color that is the same color as where I was writing it, 8 valence electrons. The maximum number of valence electrons that you can have is 8. Okay, and that's something new that we just went over yesterday. Okay, So this row, this column has one valence electron. Then when you go over here, this column has two valence electrons. You skip all of the guys in the middle because they can have different numbers, okay? Group 13 has three valence electrons. Remember, you can't have, so the other thing that you're going to do is you're going to look at group 13 and say, yeah, man, group 13 has 13 valence electrons. No, you cannot have more than 8 valence electrons, no more than 8. So this group has 3, okay? See the kids going by outside. The next group has 4, okay? So carbon has 4, and when we draw shapes, we'll have carbon in the middle of a lot of our shapes. Nitrogen in the nitrogen group has 5, 6, 7, and then 8, but we know that helium is weird, so it's 8 or 2, okay? And so when we look at these, we've got to go through and identify which groups are which. So when you go through and look at which groups are which, okay, you have, let me get my chat out of here. Okay, the first one is fluorine, okay? So fluorine, if you said that it has 9 electrons, you are 100% correct. However, it does not have 9 valence electrons. So fluorine looks like this. Let's go here. Fluorine, this first layer, okay, here's your nucleus. This first layer, you have 2 electrons. Then you have the second layer where you have 7 electrons. And we're going to talk about what that specifically looks like. Okay, but remember, because it's in group 2, or excuse me, period 2, it's going to have 2 rows. So some of these electrons you can't share. So fluorine, if you go back and look at fluorine, fluorine has 7 valence electrons, okay? And most people got that right or had a little bit of trouble because they knew what electrons were before, not now, okay? Or excuse me, how many total you had and not, you know, what we're looking at here. Beryllium is over here, okay? And we know that this whole column has 2 valence electrons. So in this case, it's in group 2, it's an alkali earth metal, whatever, okay? That means beryllium has 2 valence electrons. Now, when you look at neon, neon is right here. It's in the noble gases, okay? And we know that the noble gases can either have 2 or 8. This whole group here has 8, and this has 2, okay? So when we see this, even though neon has 10 total electrons, okay, neon is full. We'll look at that here today. But that means it has a grand total of 8 electrons to share. Okay, the electrons below it are stuck. Okay, they're stuck in the inside. So there's neon. Okay, then you got to look over here. You got to find arsenic. All right, arsenic is in group 15, which means arsenic has 5 valence electrons. Okay, 5 valence electrons. Potassium, okay, potassium is super, super, super active. Okay, it like blows up in water and stuff. And that's because it's in this row and it only has 1 electron that it needs to get rid of. It's throwing that electron at everybody. I need that electron. So it has 1. Okay. Going through, then you have sulfur. Okay, sulfur is over here with oxygen. So sulfur has a similar characteristic as oxygen, and it has 6 valence electrons. Okay, we will practice this some more. You have got to know this topic. Valence electrons is very, very, very important. Not because it's like on its own, like this big thing, but because we're going to use it today, tomorrow, moving forward. Okay, so it's very important that you know valence electrons. All right, and so we did that with your vocabulary. We talked about it yesterday. It's very important that you know valence electrons. Okay, so why will you not go? Hold on a minute, it's being stupid. There we go. All right, this thing just started over. Hold on a minute, this thing's being stupid. Let me go through here. All right, let's try this again. Here we go. Let's see if it'll work now. Stop being stupid. There we go. So today we are going to talk about Lewis structures. Okay, and Lewis, just to give you a little bit of background, was a very, very admittedly brilliant scientist. Okay, however, no one liked him. Okay, he was just the biggest butt. Okay, he was nasty to everybody. None of his assistants liked him. Okay, and so he went from job to job, and a lot of colleges wouldn't let him study there and things like that. And he came up with this, the Lewis dot structures. Okay, and he was so poorly liked that he should have won the Nobel Prize for this. Okay, he should have won every prize that there is. This is how we know how elements go together and everything. Okay, but they didn't offer it to him or give him any sort of prize recognition until after he died. Okay, and it's kind of sad. He was working in a lab and he poisoned himself with cyanide. They're not sure if it was an accident or if it was on purpose. Okay, nobody liked him. He was the worst. Okay, but he was a very brilliant scientist. So here's how you do Lewis structures. Okay, these steps are very easy. Okay, but these steps are revolutionary. Okay, this is how we identify things, and this is kind of what we look at. All right, so the first step is you are going to write the chemical symbol. This is important. Okay, this slide is important. All right, so this is basically the whole thing that we're doing today. This is a summary of everything. All right, today we're doing Lewis structures. This is how you do it. All right, so in this case, we're looking at phosphorus. P is phosphorus. Okay, so the first step is write out the chemical symbol. There it is, P. Okay, then you have to be able to figure out how many valence electrons it has. All right, if you look at phosphorus, I'm scared to exit out of here, but phosphorus is in group 15, which means it has 5 valence electrons. So what you do is you go around the outside, okay, and you say 1, 2, 3, 4 first, okay, and then if you need to, you double up after that, okay. The reason you don't double up is electrons hate each other, okay. Electrons can't stand each other, all right. They're the same charge, so they repel one another. So unless they absolutely have to, okay, they're not going to be beside each other. Okay, back when, you know, we rode buses to school and, you know, things like that, or you're riding in a car, okay, chances are you're going to spread out in the bus or in whatever car you're riding in unless you have to. Okay, so if there's 4 seats in a car and you have 4 people, they're going to spread out. They're going to go to different seats. Okay, however, once you get another electron in there, it's got to sit beside somebody. Okay, and everybody's looking like, man, you ain't, you know, if you ride a bus or anything like that, you're like, don't you sit beside me. You're trying to like either not look at them or look at them and be intimidating. Like, don't sit near me. Okay, this is what we see. So when we go through this, all right, we're going to practice these here. Okay, but selenium, krypton, and strontium. Okay, so what you see is strontium. Okay, and again, we're building, so this is why I said valence electrons are very important. Strontium is in group, move this out of the way, group 2. Okay, which means it has 2 valence electrons. All right, so the first step is you write the symbol for the element, and then you put dots around it until you fill up all of your electrons. Okay, it only has 2 valence electrons. We know it has more total. So you go 1, 2. Okay, we'll talk about it. This is also right with the dots on both sides. Okay, or you could take a dot and you could put it here. Okay, or you could put it here. It doesn't matter. But the main thing that matters is you have to spread them out. Okay, they're going to go their own different directions until you get to 5, 6, 7, or 8 electrons. Okay, so let's look at krypton. Okay, krypton is a noble gas, and we know the noble gases either have 2, like helium, or they have 8. Okay, so what you have to do, the first step is you write krypton, then you go 1, 2, 3, 4. Okay, this is basically like it's a box. Okay, and each side of the box is like you have to fill up that side of the box first. Okay, so you don't have to draw the box, but it's there. It's an invisible box. Okay, so you have 4, 5, 6, 7, 8. The maximum of number of valence electrons that you can have on one side is 2. So you can have 2 here, 2 here, 2 here, and 2 here. And the maximum number you can have is 8. Okay? So basically, every element is going to be like this. And the absolute maximum number of dots you can have is 2 on each side. Okay, so depending on what your element is, if it has 7, it looks like that. If it has 6, it looks like that. If it has 5, it looks like that. 4, 3, 2, and 1. Oops. That's what it looks like. Okay, so it's very simple to do. All right, and we're gonna see that. Now, what you're going to do is there is some practice. Okay, and we are going to work on this practice. I'm going to show it to you first. Okay, this video is going to show you all about Bohr's model and how when things go down, they have different colors, okay, that are emitted, and we're going to look at that a little bit later too. Okay, but the important thing is, one, to get your stuff done from yesterday, but also to look at your Lewis dot review. Okay, so when you click on this, still makes me make another darn copy of it. I'm gonna have to delete this in a minute. Okay, but what you're gonna go through, okay, is you're gonna go through and look at this. This is very, very, very simple. Okay, 4 questions going through to kind of make sure that you have that stuff, because you still have your vocab, you still have your unit 1 reflection, and you still have your work from yesterday. Okay, very, very, very simple. All right, and so you're going to answer what makes an atom stable. Okay, and there's a couple of answers about that. Okay, there's a few things. As you can tell, the sun is moving, so now it's like in my face. Then you're going to answer how many protons, neutrons, and electrons does oxygen have. Now, here's what you're going to do. You're going to say, yeah, it's got 3, 4, and 6. That's not really how many it has. And not explain how did you arrive at your answers. If you do not explain, I am not giving you credit for number 2. You're getting half credit. Okay? So don't just go in and do the bare minimum. Go in and do it correctly. Do it right the first time. Okay? Then you're going to tell me how many valence electrons does magnesium have. Okay? If you write, and again, this is wrong, but if you say the answer is 7 and you don't say how you got to number 7, you're not getting credit for number 3. So realistically, you really have 2 questions here and 2 questions here, and 1 question here and 1 question here. Okay. Lastly, you're going to draw the Lewis diagram, which is this with the dots around it, okay, of nitrogen. All right, that's it. We are seeing whether or not we know what the heck is going on. Okay, we're seeing whether or not we know what the heck is going on. All right, that's it. So you're going to go through and work on that. And I am going to be available for any of the questions or concerns that you have. Now, you've got to make sure that you're getting all of the stuff done that you need to get done for your Canvas. Okay, you got to make sure that you're getting all that stuff finished, because let's see what I have to grade left for y'all. I got not very much. I really only have like 2 things left to grade for y'all. Okay, so some of you guys have not done your atom builder, and some people have not done your Bohr's model. So you got to get that stuff done, which is why I'm giving you as much time as I am. Now, here's what we're going to say, okay? If me giving you this much time, you're still not getting work done, okay, we're going to stop getting this much time, because realistically, we could go on and move on to something else. We didn't go into a lot of stuff today, okay? So you have got to show me that me giving you this time is translating into work being done, okay? Got to make sure that you're showing me that me giving you this time is translating into work getting done. Okay, I need to see stuff being submitted. All right, so go ahead and get started on that. I'm uploading last period's video, and I'll be here to answer any questions that you have for me. Okay, let's go.